Okay, so let's get started. First thing what we're going to do is we're going to change to composite view and we're going to set this to image compositing. I'm right over here already in the network. So first thing that we want to add is like a file. So press tab, add file, and we're going to use an image just from the internet. And this is something nice from Houdini. Actually, you can use directly an internet link. So let's look for a girl. There's always beautiful girls to find on the internet. This is like a nice girl. Look over here. We take the internet link, and what you can do is just go over here, and where you have the file location, we just set the internet link. And there you go. Okay, there's just one thing which is going on, is that over here you see this image is like very dark. It's because of my previous setting. I'm going to change it back to what it was. And so probably you have it exactly the same, like over here. We're going to change it later, so to show you what's going on. Or in fact, we can do it just right away. Where is it? Okay. Now the reason why this is set is because of the following of some default settings that you have. First of all, when you load in a file, you see over here linearize non-linear images. Now most of the images, right, they are non-linear images. They have been corrected, especially if you download them. But basically, what I tend to do, or especially when you start to work on these images, what I tend to do is to switch this off, to switch off the linearization, and then you don't need to have the gamma correction over here as well. So this leaves you with this image as you see it right now. All right, so let's see if we just linearize, then you see actually, let's say, the more direct contrast. Now, if you want to know a little bit more about this, then you can go to this link over here, that is Cambridge in Color, and there they do like a very good explanation on what the reason is why gamma correction is being used. So you find it over here in this link. So I would suggest to take your time to have like a good look on it. Alright, but that's not the purpose of this lecture. So let's go back. Let's set it immediately as we want to use it. Okay. Fine. So we have this image, and the next thing that we're going to do is we're going to add a null node. And the reason that we're going to add this null node is that we're going to refer to this node with expressions, etc. And instead of referring to the file directly, if you refer to a null node, you can easily switch the image coming into that null node. Makes it much more convenient. Otherwise, you always have to change the name again, which doesn't make it very practical. So let's rename it to out comp. And the thing that we're going to do now is we're going to move our data, our image data, into the 3D space. So we need to get it into a SOP context level. So if you press tab and we go to managers, you find over here in the managers a SOP network. So let's go over here. And the object that we're going to create to represent our data is something which is going to be quite similar to an image. So we're going to use a grid for that. Now let me change back to scene view first. And let's add a grid object. So there are a few things that we want to do in order to get this grid object right and easy to handle with. So if you see like representation of images or coordinates on images, you see them often being represented by UV values or UVW values. So UVW, you can also look it as being the X, Y, Z coordinates. So UV would be well represented by x, y. So that's the first thing that we're going to do. We're going to set our plane into the x, y direction. Now you probably have like different values over here. This is my preset with some expressions. And you have like probably a 20 by 20 or a 10 by 10 size with a 20 by 20 subdivision or something similar to that. So make sure that first of all you have a size set to 1 by 1. We want to have like the full representation of the image, but not more and also not less, of course. Now we also want to have the center of our grid being placed right over here so that we get like the full representation of the grid. Right now, if you look at the coordinates, you see over here, this point is at a half x and a half y, and this one is over here minus half x and half y. So we need to get this point to, let's say, 0 and this point to 1. So we're going to set this off by 0.5, 0.5. So now we have like the correct representation, or the correct size at least, that we can easily map our image towards. There's still something else. If we look at the points over here, we just have 4 points, and this is of course not representing the number of pixels that we have. So if you look back to the composite view, we see we have like a 768 by 480, and we need to represent like each pixel into a point. So that's going to be a lot of points. So let's see, how can we deal with this? Well, first of all, there's like a easy to use expression. It's called res. So let me first find this over here that we can show it. So if you look to res from resolution, we look in the help file until we find over here the res expression function. So if you look at this expression over here, we find over here the node that we want to use, and then on the other hand we find also the type. The type which can be either used with a name or also with a number. I'll show you both. So let's see over here. Okay, so that's the expression that we're going to use to put it right over here. Now there's one little detail that you need to know over here, and that's with the ordering for the grid. The rows are in fact the horizontal division, and the columns is the vertical division. So it feels a little bit unnaturally, but that's what it is. So if you take res and we want to get like our data, let's go up one more time, 2 more times, go to the outcome. We can find it easily now with the proper name. And then we're going to set the type d_y res. Like this. So if we check the result, we see over here we have like 480. So let's copy this and let's put it over here. Let's make it the x res, and we see over here in the width. Now how can we check whether this is okay? So if we zoom in, you see the proportion of the division. So we see there's much more division over here on the horizontal axis than there's division on the vertical axis. Right, so now I said that we can also use a number over here, so I'll prove that to you. So if I press 0 and I press 1 over here, then you'll see we get exactly the same result. Or let's make it just the opposite way so that you can see it changes actually. Alright, so d_y res of course makes it much more easy to read and understand what's going on. d_x res. Right, so let me just remove this number of points. The next step that we want to do is we want to get our colors from the image onto this grid. So how can we do this? Well, I'm going to show this using 2 methods, either using a VOP SOP or using an attribute wrangle. So let me start with the VOP SOP. So VOP SOP. Basically they're the same. The only difference is that one is using a network-like representation of the VEX language. The other one is just VEX directly, or vex expressions. There are some slight differences to them, but that's something for another lesson. So what we want to get is we want to use a color map. And so using this color map, we're going to get like the point information of our image. And there are a few things that we need to connect first. We're going to connect the U and the V value. So how can we get like the proper sampling, the U and V sampling? Well, we can do it right over here. We can use our point right over here. So what I'm going to do is I'm going to divide the vector up into other things. So pressing tab, vector to float. So vector comes in, 3 floats come out. And so the first 3, x, y, z, so the first 2, x is going to be connected to u, and y is going to be connected to v. So this is already giving us this little part. Now there's something else we need to get. We need to get like the color map to get it where it's coming from. So right now by default there's a mandrel pick. So if we connect it to color, you see the mandrel appearing right over here. Now same thing, what do I have? If I press D, you have it differently. Let's go to the viewport again and set the camera correction to 2.2, like this. So this gives you more or less a good representation. The other thing which I also tend to do, but yeah, perhaps I'll come to that a little bit later. So what we need to do later on is we need to make sure that the colors that we see right over here are going to match exactly the colors that we see in our compositing. But we were talking about using the color map. So let's go back to color map. Right over here, if we see the CMap, if you middle mouse button press on this output, you can promote the parameter. So you see like this little dot coming up to it. So now if I right click on this little dot, I can expose the inputs, and we see over here the node appearing for creating a string. Okay, now let's go up. This has created a parameter. So if we go up, we see the parameters appearing right over here. So the thing that we're going to do now is we're going to refer our color map to our node in our compositing part. So there are 2 ways you can do this. Well, one way that you can do is you can use, for example, exactly the file which is coming in. So if we go up over here, you could read, okay, I have this incoming node and I'm going to read what's right over here. Now that might be a good idea, but the problem with that is if we would add, for example, let's say a mat operator with a ramp, and you would connect this one, well, this doesn't have like a file, so you can't read it, and therefore this node is not going to work. So we're going to do it using a different method. So another method is by using actually the data of the operator, and that starts by typing OP and then adding the full path name of the node that you want to refer to. And so the full name is in this case going to be /image /comp1 / and then the out comp node that we created. So now we see that we get directly this image. Now what's good about this is that at this moment we can change the image, and as you can see, even with a different resolution or different colors or whatever, it's going to be updated automatically. So that's a good part. That's how we can get like our image onto our points over here using the point fob. Now let's do the same using an attribute wrangle. So attribute wrangle over here. So now we're going to type in the code directly. So we can do this now over here by setting the color. So we're going to run over points, which is important. This is something we're going to set on each point, the color. And to set an attribute, then first press the add sign and then CD for the attribute of the color. Alright, so what we're now going to do is we're going to use again the color map. We see the function appearing over here. Again, we need to set the node. Now, we can't set the node directly over here, or we might be able to set it, but we're going to do it differently. Here I'm going to set a channel string, and the channel string is going to be named, let's say, file. And then we're going to need to set the U and V coordinates again. So the U and V coordinates, we're going to do this by using again the position attribute. So in this case, type add again, position attribute, and the first one is going to be position of X, and the second one is going to be the position of Y. And then always close off with a point comma. Okay, we don't see anything over here. Well, it's logic because right here we didn't add anything. Oh, I don't see that I don't have an interface. Well, this is really nice about this. We see over here we created a channel file, and so if you click over here, then it's automatically going to check the code to find if there are these things which are not connected yet, and it's going to automatically generate this string or this parameter for us. So now we're going to do exactly the same thing, but I'm going to make like a slight modification. So up again. Now instead of typing the path fully myself, what I'm going to do is I'm going to create like a relative reference, but then use an expression to make it like a full reference. So we call this, or we're going to use a function op full path, and then we're going to refer to the node outcomp. So if we're going to look at this, as you see, it works. And if you middle mouse button click on this, you see the result of what this expression is generating. Perfect. It's exactly what we need. Okay. Good. So we do have like two methods now. I'm going to continue with the attribute triangle. So we now have like the colors right over here. The next step is going to be, we're going to change each pixel color into a position. So I'm going to use a new wrangle for that. You could do it with the same wrangle, or you could do it with a point VOP. It's quite the same. So what we're going to set now is we're going to set the position of the points, and the position is going to be set by the color. So we just transferred data from one to another, and that's what we see over here. So this image now has been converted into a 3D spatial representation of the colors. Now, from this result, or something similar to that, the thing that we're going to do is we're going to bring this data back into an image, into the compositing node. So, and the reason is because now we will be able to do all kinds of geometrical operations on this image. And these geometrical operations, if we then read it back into the image, we're gonna get like the nice and proper color representation of that. So I'm going to add again a null node that we're going to use to read out from here and to bring it back up. So let's rename this one to out sop. So now what we're going to do is we're going to get our 3D information, the positions of the points, and we're going to get it back into an image. Now the way that we're going to do this is using a VOP CopFilter. as we can see over here. So we connect the first image right over here. Make sure that you have your viewport set to image. And as you can see now, the image is just being wired through. We get exactly the same resolution, etc. So how can we get our data? So what we're gonna do is over here, if you press tab, you see there are like in FOPs always all kinds of nodes, but also the nodes which are relevant not only towards compositing, but also towards geometry, which we find over here. And we're gonna get over here the get attribute node. So what we're gonna read is the position of these points. Now, a few things. First thing, I'm going to middle mouse button click over here to promote the parameter. It's just like we did before. And then right click to expose the inputs. Now we see here by default, disable when the op input is not a file. We're going to remove it because if we're gonna leave this on, then you're gonna see that we can't edit this over here because the op input is not a file. Here we go. So we change this and now we can edit what's going on over here. So we're gonna do exactly the same thing. Op, we're gonna use the double point. Operation full path. And so now we're gonna take the null node which we can find inside of the subnet. So 2 points to go up one time. We go over here into the subnets and then we have the outsub, which we can easily find because of our proper name convention. Alright, so let's see. Always check, middle mouse button click, everything is working, so that's fine. Now let's go over here. The other thing we need to do, okay, our data is represented as a vector and we need to plug it into the RGB over here. So we're gonna take like a vector to float, take the position values and connect these to the R, G and B values. So right now everything becomes black, which is logical because we haven't connected anything over here to which point we need to get our data from. So how are we going to do this? Well, there are two things over here. Here we have like the IX and IY. This is the integer pixel value of both the X and the Y. And so we need to convert both of these towards something which is like a constant counting up. Now how do we need to do that? So if we go back to our scene view, and let me go up over here right to this spot. Let's see it when it still is a neat plane. If you're gonna look closer, we see our values are counting up. So from 0, 1, 2, 3, 4, 5, it goes the whole row and then goes up 1 time, 2 times, etc. So it's nicely following what we need. So we're gonna do the same over here in the FOP CopFilter. Yeah, right now it's not working, so it's just, oh, sorry, now I'm showing something different, the composite view. So let's go in here. And so we need to get this to an uprising value. So over here, the X pixel value is for each pixel in the X direction, 0, 1, 2, 3, 4, 5, and going up. In the Y, it's doing exactly the same. So we need to combine both of these in such a way that we have like this constant upcounting value. And the way how we can do this is by multiplying, follow closely, multiplying the Y value, so the ones going into the height, with the X resolution. So how does this work? So we have at one time 0 times the X-res is going to be 0 for everything. Then 1 times the X resolution, so we're going to get like 768, and then we have double that, etc. So this one is something we're going to add on top to the X value, which is going to count every time from 0 to 768. So 0 to 768, 0 to 768, 0 to 768, and each time we're going to add like this Y value to it. So if we connect these two, and now we connect it to our point, we get our image as we can see over here. So that's actually the part covering loading in an image, putting our data into 3D, showing it as showing or representing the colors as new positions, going out again and reading that result back in composite view. Now let's test whether this is working properly. And if this works properly, then we're going to play around and show what we can do. So let's say if we add like a transform operator. So remember that we have like all these positions over here of these points. So if we start to fiddle around with this, if we start to rotate this, then we're gonna see like a difference in our result in the composite view, the CopFilter1. So let's see whether this is working. Okay, first thing that I'm going to do is I'm going to put my pivot points in the center of this all, so I can also use rotation. So let's see and start to rotate over here. And as we can see, it works. So our image is actually indeed changing because we are adjusting the points, their positions, and we're reading those positions out to reconstruct a new image. Okay, so this is going to be the first part. In the second part, we're going to do like a transformation into different color spaces. And also we're going to do some different kinds of operations, which is going to show some interesting results. So this concludes the first part. So we'll conclude with this video and we'll continue with the rest in the next video.